Hello, this is Miss Lee again, and today we're going to talk about simplifying algebraic expressions. We've been working a lot with algebraic expressions. We know how to model them. We know how to translate verbal phrases to algebraic expressions. We can evaluate expressions. We can use the distributive property to create equivalent expressions, as well as the other properties of operations. And now we're going to simplify them. Okay, first let's review the parts of an algebraic expression. All right, so we have terms. Remember, the terms are separated by plus or minus signs. So there are three terms. We have 3x, which means 3 times 7. We have, 3 times x. We have 7, which is a constant, and we have 1x. Okay, the terms 3x and x are called like terms because they have the same variable. 7 is not a like term because it does not have the variable x. The 7 is the constant. Remember, it's just a number. Okay. So the 3x and the x are like terms. When you have like terms, you can combine them. So 3x's and this is 1x. If we combine them, it makes a total of 4x's. So we could simplify this expression to 4x plus 7. And this is all we can do. We don't know the value of x, so we can't evaluate the expression. Coming over here, these arrows are pointing to the 4n, the 2n, and the 9. These are your terms. So again, we have three terms. Then you want to look at the just a number. This is your constant. And as you'll recall, those numbers that are attached to the variable, that are being multiplied with the variable, like the 4 and the 2, those are called the coefficients. When you're combining like terms, it's the coefficients that you combine. So to simplify an algebraic expression, we generate an equivalent expression that has no parentheses and no like terms. Okay? Just like simplifying fractions, we want to make them smaller so they're easier to work with. The same is true here with algebraic expressions. We don't want to work with an expression that has a whole bunch of terms. We want to combine all the like terms to have a simplified or smaller expression. Take a look at A. X plus x. Do we have any parentheses? No. Do we have any like terms? Yes. We have an x and another x. So combine them together, and that gives you 2x's, or 2x. Look at B. We have negative 4 times 6x. Do we have parentheses? Yes. Okay, now this isn't a distributing parentheses. This is just multiplication. We're multiplying negative 4 with the coefficient of x. So negative 4 times 6 is negative 24, and then don't forget to add the x there. Negative 24x. Example C. We have three groups of x plus 11. So when you have groups of something like this, 3 groups of something, 2 groups of something, this is where we want to use the distributive property because we need to get rid of the parentheses. So we're going to share out the 3 to each term inside the parentheses, and that operation is multiplication. So we have 3 times x, which gives us 3x's. We bring down the operation symbol, and we're going to share the 3 with a constant. 3 times 11 is 33. Do we have any like terms that we can combine? Well, this term has an x. 33 does not. So no, they are not like terms. This is as much as we can do. 3x plus 33. Look at problem D. 3 friends will pay X dollars each for admission to the museum, plus $1 each to view the mummy exhibit. A fourth friend will pay admission, but will not view the mummy exhibit. The expression 3 groups of x plus 1 plus x represents the total cost. Simplify this expression. So I'm going to write it over here so that I can work with it. 3 groups of x plus 1 plus an additional x. First thing, are there parentheses? Yes. You always have to get rid of the parentheses first before you can combine those like terms. So we're going to share out this 3 with each term inside the parentheses. So 3 times x gives us 3x. bring down the operation symbol, and 3 times 1 gives us 3. We haven't done anything with this x down here. It's not inside the parentheses, so we're not going to share the 3 with it. We just bring it down. This is kind of like a two-step problem. Okay, now that the parentheses are gone, we can combine our like terms. Do we have any like terms? Well, I'm going to start with the first term, and I'm going to put a box around it. 3x. So this term has an x. Do we have any other x terms? Well, this is a constant. Oh, here we go. We have another x right here. So 3x's plus 1 additional x will give us a total of 4x's. Then the next term, or the only term left, is the constant 3. Okay, the 3 does not have a variable, so it's not a like term with our x's. It's just a constant. So we have 4x plus 3, and that's as much as we can do.